if you haven't done it yet, just go off and finish it because we do have another SAC. I'll record this and you can come see this a bit later. So during rare parts of Mercury and Venus's orbit, the angle of the Sun to Mercury to Venus is a right angle as shown in the diagram. The distance from Mercury to the Sun is 60 million kilometers. So the distance from Venus to the Sun is 110. So I've got a diagram here, but I don't have distances on there. So I'm going to put that in. Distance from Mercury to the Sun. So we're starting from Mercury to the Sun is 60 million kilometers. The distance from Venus to the Sun, is 110. What is the angle from Venus to the Sun to Mercury? So we want to know what this angle is here, which is already listed. Round your answer to the nearest minute. Okay, so when I think about that, this is a right angle, as they're shown in there, because it does say the angle from the Sun to Mercury to Venus is a right angle. So from the Sun to Mercury to Venus is a right angle as well. So I know it's a right angle triangle. So basically we're dealing with this. It's a right angle triangle. I want to know what this is in here. I've got 60, I've got 110, and I'd imagine most people were struggling with the minutes of this. So let's have a quick look at that one on the CAS. So when I think about this, I have my adjacent, I have my hypotenuse. So in terms of, I'm going to use cos for ca, okay? So I want to know what my angle is. So it's going to be the inverse of cos. So my angle will equal the inverse of cos adjacent over hypotenuse, which is 60 over 110. Now, I don't have to put it as like a million kilometers because it's just a ratio, and that is fine. So on my CAS, I'm going to put that in. Bring up my keyboard, go to trigonometry. I'm going to do a cos, open bracket. I like to put a fraction in. It's already got a bracket there. Whoops. And I'm going to go 60, press down, over 110, press across, close my bracket, close it again. Hit execute. Now there you'll notice I need to change this into minutes. I don't know if it does it automatically into minutes. No, because I know on the other CASs there is. I wonder if you can actually transfer it. It should be here.
So if you go to Math 1, there's like 2 DMS.
Ah, thanks. Yep, degrees, minutes, seconds. Thank you. Excellent. I thought there would be a button. There is on the other ones. Highlight this. 2 DMS. No, how do we do it? Do I just put this in?
You click.
Oh, right. Okay. Oh, I see. Like that. Okay. Oh. Let me just delete all this. All right, my CAS is having a meltdown. Delete away, clear. Let me try that again. When everything goes astray on your CAS, clear all and clear all variables. Let's just do that. Okay, that 2 DMS, thank you, mass 1, degrees, minutes, seconds. So we're just going to take this, put this down here, hit execute. Oh, beautiful. Look at that, does it for you. Alternative, what you're really doing is you try and actually divide this by 60, times that by 60, sorry. There's a decimal place though, it should be 0. And you'll find you get 56 minutes and then you've got to change this into seconds. So you've then got to times that by 60. And as you can see, it's a lot longer to do, where it's a lot easier just to hit the 2 DMS one. And 39 minutes, 39 seconds, point da, 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 da. So we can see to the nearest degree, to the nearest minute, if I had 56 minutes and 39 seconds, would I round up or down? It's literally time. You're going to round up because it's closer to 57 minutes than what it is to 56. So it's going to be 56, 57. So we're going to go into this one. 56, and in here, in trig, we should, oh, it's in one of these. There should be degrees. There should be degrees. Here, angle. There you go, degrees. 56 degrees. I'll put a fraction in there. So, in angle, degrees, 56 degrees is what I said, yes. 56 and 57 minutes. Press across to come out of that, 57, and that is the minute mark. This is the second mark. Oh, what have I done wrong? Do I just want it like that? No. 56 degrees, 57. Should be 57 minutes. Oh, I had it as an indice. That's why. I must have pressed something wrong. Not right. Just delete it. Try it again. There we go. I had it as an indice. I don't know why. I think I pressed the wrong button. I had it as a fraction still, and it was as an indice. 56 degrees and 57 minutes. So that one there is good. And thanks, Dollar, for that one. 2 degrees, minutes, seconds. Super easy. Did not know about that one. Let's share that one with the team. Which set of data does not determine a unique triangle ABC? The side lengths opposite the angles ABC respectively. Okay, so which one does not determine a unique triangle? So what we mean by that, a unique triangle, is basically if it's not unique, it will make more than one triangle. It doesn't have enough information in there. So I reckon that's an ambiguous case of a right angle triangle because that is not unique. It could have 2 triangles in there. So if we look at ABC, I can have A as 12, 13. Well, let's do C as 13. I don't know, I was thinking that. This could be 12 and this could be 5. Now that's going to be unique because it has to be fixed. Like that can only be 5, that can only be 12. You can't change it. If we've got A equals 6, we've got B equals 4, and then we've got C equals 70. So C would be down here, and this is 70 degrees, right? Because that would be angle C, that would be length C. If you think about this, this is fixed, because if that's 70 degrees, that goes out on 4, 6, and that goes on 4, it'll probably be more like that. It's fixed, like you can't change it. It's not an ambiguous case of the sign rule. So if we've got A equals 80, C equals 30, so you've got 80 degrees. You might have, oh, this is going to be hard for me to draw like that. So you might have, this is 80 here, 70 there, and 30 degrees here. That would be unique because it's all same structure. This last one, if we've got A is, do that one. Yeah, if we've got A is 20, I feel like I've gone about this the wrong way, but I don't think it is. This would be 20. Let's call that angle A, and you've got B as 40. Let's call that one B is 40. And you've got C is 8. That would be all locked in. So which one is not unique? Have I done this one right? Yes, that's acute. That's 6. That's 4. If that's 70, that would be fixed and that would be unique. 30. This one. Could be different because I could actually move the order of them. But it doesn't matter because that's just rotating. All right, I'm going to take a guess on this one. And we'll see what happens. This is a good question. I feel like it's not going to be that one. Let's have a look. I'll give it. Oh, C was correct. That one's not unique. I want to explain that is because I think you can have a few different triangles on that one. Feel free to jump in, guys, if anyone wants to help me explain this one. So if I've got 30.
Sir,
Yes.
Steffi's having internet problems, so he can't join.
80. Okay, thank you. And then we're also going to have 70, right? So if you've got that, I've just drawn blanks on this one. I'll have to come back to that, guys. Let me come back to this one. No, I'm going to come back to that. I'm not going to close that. I think what I'm thinking is why it's not unique is because we can actually change where these occur. So you could have 30, 80, 70. But, of course. Of course it's not unique. Come on, I can just click with it. Anyone? Anyone got anything? Any questions, comments? Why it's not unique? It's so obvious now. What does a unique triangle need to be? A unique triangle means it's only one type of triangle, like it's fixed. You can't have multiple types of triangles. Does that make sense what unique is? Are you guys with me? Do you understand unique means it's only got one? It's so damn obvious. It's annoying me now. I was struggling with it. And now I'm like, oh, that's so obvious. All right. Well, obviously, you guys aren't getting it. Think about this, right? We don't have any idea what length this is. So this could be like 1, and that, who knows what it'd be. That could be also like 5, and you've still got the same degrees like in there. You know, like that's 80. I'm not drawing this right. Like that would be like 70, 80, and that would be 30. These are the similar triangles, but they're not unique because I can scale them up and down. I was straight away when I went into this, I was looking for the ambiguous case of the sine rule. And that's where I was trying to like really go, look, you know, it's the ambiguous case of the sine rule. And I was trying to see for 2. I wasn't thinking of similar triangles because similar triangles you can scale up. Because we've only got the angles, we don't know about the lengths of any of them. That's why they can be there. So I was sort of drawing blanks there and I didn't really know what happened. And what I actually did is I went back and said, okay, I got no idea about this. I've spent way too much time trying to ponder through this. I should have moved on earlier. So don't get yourself caught into that. And then what I realized and what I thought was, okay, and I did want to help you guys out. I thought, okay, what do I know about the study design? What else do I know about? What else have we looked at? And I was going through my head. I've done Pythag, I've done SOHCAHTOA, I've done the sine rule, and biggest case of sine rule. I kept on coming to that cosine rule. And then I sort of started going, through the topics. We've done bearings. We've done similar shapes. I'm like, similar shapes. I'm like, okay, hang on a moment. Similar shapes, you can expand and go down. And when similar shapes, you can actually get, they're not unique. They're different. And that's what I'm like, So if you ever struggle with something, move on if you need to. But if you do come back to it, try and think of, because in the exams, and they're actually structured into each subtopic area. So we can only ask you so much on that. And just think about, well, what have we learned? What have we covered? Because I can only ask so many questions on that. So I went to that and I'm like, similar shapes, of course. So then that stood out to me. Why the answer for this one is, that's why that one's the answer, because you can have multiple triangles of that because you're not fixed. All the others have fixed lengths. And I was stuck with ambiguous cases as the sign rule. So it just shows you sometimes when you think, oh, you preempt something, you kind of block yourself out with other thoughts. Does that make sense? 0 to 5, why that is not a unique one, and why that's the answer. And I kind of had a gut feel about it as well, because I knew these were unique, and I couldn't eliminate that one. Like I kind of knew that they were unique, I suppose, when I did it. I'm like, well, no, that's definitely like set, that's set, that's set. This one, I'm like, I couldn't really explain why it was unique or it wasn't. So that's kind of why I went with that. So I sort of used an elimination of, I feel really comfortable about the other three, and that's why I took a guess on that one. So that's a way you can work through that. I really would like to see your feedback, if that makes sense, why it's unique or not on that. All right, let's go to the next one. Oh, phew, sweating there, doing a SAC. During a group hike, a hiker walked 9 kilometers northeast of base camp. In the evening, the hiker was separated from the group, and after a night lost in the wilderness. Oh, look out. The hiker was found 9 kilometers northwest of base camp. What bearing must the hiker have followed during the night? We're assuming they walked in a straight line. Let's take a little picture of this one. We'll just
Mr. Rainbow,
yes?
you can draw on the actual thing.
Yeah, I do. Sometimes I can't. Yeah, this one. Yeah? Is that what you mean?
No, not on the snippet, on the website.
No,
Next
I
to
didn't.
the 3 dots at the go.
Oh,
Yeah.
wow, look at that. Let's do that. Thanks heaps. During a hiker walked 9 kilometers northeast. Why has no one ever told me this? And I've done so many of these. Why has it only taken like a year of lockdown? Anyway, thank you. He walked 9 kilometers northeast of base camp. So let's do base camp here. Okay. All right, I see why people maybe don't draw on this. We'll try. We'll give it a go. So this is base camp, and he walked northeast. Okay, so that's going to be that way. Again, when we're doing these roses, as I tell you guys, always over-exaggerate these. All right, and draw them really, really large. The hiker was lost and found 9 kilometers northeast of the base camp. So northwest. So northwest is this way. So, whoops, they should be... And don't forget, these are both 45 degrees. Yeah, I can see what that. I'm going back to this one. Okay, this one I prefer to draw on. It's going to be a lot easier because I can actually see what I'm drawing. Here's my base camp. So we went, oh, that is so much easier. So, but thanks for that. Anyway, I think that did help. 45, okay. This one here is also 45. Hey, look, because it's northeast, don't forget, and northwest. So that actually makes one big right angle triangle here. So we're asking how far he walked. And obviously if he's walked 9 kilometers this way and, it's 9 kilometers from there, we know that, well, if that's a 45-degree triangle, that's right. And this is an equal an isosceles triangle. Well, we know that that is just going to be, if he went to here, that's where he walked to, right? So they went from northeast, and in the evening, spread from the group. After a nice loss, the hiker was found there. What bearing must the hiker have followed during the night? Well, he's gone west during the night. So due west. There we go. So due west would be my answer for that one. Any questions, comments? No? Okay, gonna move on. This one. Find the volume of the figure correct to 2 decimal places. All right, this is not surface area, it is volume. Just really make sure you reread the question before you go into it. I have seen some people start going into total surface area where it was volume. Got everything right, but it said volume. Corrected 2 decimal places. Reread the question again after this. I know I need to because I always stuff up this. Okay, so this is 3/4 of a cylinder volume. So cylinder volume is the area of a circle times by height because it's a cross section. So it's height by the area of a circle, which is pi r squared. And I'm going to times this by 3/4 because it's 3/4 of a circle. So the volume will equal 11 by pi by the radius. This is 3. That is the radius by 3/4. And that would be it. Are we all in the same units? Yes, we are. That's myself there as well. Oh, I feel so much better about this one compared to that triangle one. Geez, I was sweating on that triangle one. Like, what's going on here? What am I doing? I'm going to do this on the keyboard. So hopefully how quick it takes you guys on this now should be something like this. So it's 11 times pi times 3 squared times, you can pull up the fraction if you want, 3 on 4, or you can do 7/5, press across, and that's it. 223.26. What is the volume of this? Correct 2 decimal places. Yep, happy with that. What did I say? 233.26. 233.26. I always have transcription errors, so I'm going to double check that. 233.26. 233.26. I'm happy with that. Yay, done. Questions on that one? Please ask questions as I go through. Okay. A boat travels north 36 degrees east for 9 kilometers, then changes direction to south 28 degrees east for 4 kilometers, and then changes one last time to south 49 for 9 kilometers. Which diagram matches its journey? No, diagrams are not to scale. Okay, so a boat travels. So where does it travel? So it starts. Okay, so if we look at this, so it starts. So it would be 9. So it would be north east. So it needs to start and go that way. That would be it. Because if look at the compass rose is how I'm directing myself. So I'm thinking north 36, and then if 36 plus 54, that should equal 90 because that's obviously going west. And it does. That makes it 60, 90. So this is a good start. Okay, so I can eliminate that. Then I'm also going to eliminate this one. So I know it's only between these two. So I know I've only got these two. So then I can see the difference is the top there. So all I got to do is go to the next point. So this is correct. Then changes direction, and it's gone for 9Ks. Both. Hang on a moment. That's only done 4Ks. Straight away it's this one. Yay. Anyway, let's do the rest of it. So straight away I can see it's that one. That's 4. So just from the first bit of information, unanswered from here. So I'm happy with that. But let's go through it and check it all anyway for you guys. But I'll probably leave it from there and I'll move on. Then south east, 28 degrees east. So if we go here, that means south. We go 28 degrees towards the east. 28 plus 62 will take me back, hopefully, to east. 62, yep, that would. For 4 kilometers, that's 4Ks. And then changes one last time, south. Start south, 48 degrees to the west. 48 plus 42 gives me to 90. So that is correct for 9 kilometers. So I'm really happy with that. I would have stopped at the first one. I love multiple choice questions because you can just get through them straight away. Okay, loading up. Oh, a paint roller. Oh, yay, I love painting. I don't. I did so much of it in my old house. A paint roller is a cylindrical shape. It has a diameter of 6 centimeters and a width of a 35.8. Find the area painted by the roller when it makes 1 revolution. Correct to the nearest 0.1 centimeter. So I've got to actually find the surface area of that. So this is probably an interpretation question, I reckon, that you guys got wrong because you didn't quite understand it. So what I'm picturing here is if I do it this way, that's kind of like a roller, right? Oh, kind of goes like this. It's better. Okay, so that's like, and they're fluffy. Like if you paint with low sheen, they're really got like a big peel on them. If you paint with like a higher sheen, they're really small, but usually they're a bit fluffy. So if it does 1 revolution, how much does it paint? Well, we know that this is 35.8. and the length, and we need to find out what the perimeter of that is, what the circumference of this circle is, because when you cut that open, if you slice that down, it would actually make a rectangle. And that's why I say to you guys that you need to understand how to find the surface area of each of these and break it down, which we've done in class before. So I know that the diameter is 6, okay? If the diameter is 6, that means the radius is 3. We know that the circumference is pi times the diameter, or pi times 2 times the radius, which is still 6. So I know that this is 6 pi long. That's 35.8. So I'm going to go 6 pi times 35.8. So, and that would get me to my answer, or 2 times 3 times pi, the same thing. So I'm going to go 6 pi on here. Where's my stylus? There it is. Times 35.8. And I hope you guys are about as quick as that on the calculator. 374.81, 674, why did I say 3? 6, 674.81. Reading it again, I did 6 pi by 35.8. I'm just going to double check my calculator. Yep, I did that right. I'm just checking that I do transcription errors. To the nearest 0.01 centimeter. These are both in centimeters, yes, which is 81. 67481. Obviously, you guys will be able to see the screen and your calculator. I've got to toggle Alt Tab. 674.81. I'm happy with that. So notice, just sort of taking that little bit of extra time just to make sure I'm not making any mistakes. Okay. Find the shaded area in the figure below. This is a parallelogram with a triangle taken out. So the area for the parallelogram is, if you think about it, it's actually just length times height, because if I cut this section off here and just whack it, will fit straight into there. So it's actually going to be still 14, because that length there will go there. So it's still going to be 14 centimeters long by 6, which will make a rectangle. So it is going to be 14 by 6 minus the triangle, which is base times height, half of it. Half times 14 times 3. So already I'm thinking it's going to have to be under, you know, it's going to be around 60-ish centimeters, maybe more, 70, 80. So get out my calculator. And I'm literally just going to put in, I'm going to show you guys how I do it on my screen. There we go. Okay, so just go to 14 times 6 minus 0.5 times 14 times 3. 14 by 6 minus half base times height. Notice I double checked that, and that's why 14 times 3. Yep, I'm really happy with that, and I'm happy with that. Notice I put in something wrong, which could completely stuff it up. So it's really important. If you guys do that mistake, you do that too. 63. Oh, I can't put my answer in on that one. I've got to go this one. 63. All right, there we go. Yeah, yell out if you've got questions, as I said. Evaluate cos within this diagram. So this is saying what the cos angle is. We did have this one in the practice test too, so I'm going to slow this one down. It's funny, it's came up again. Let's just go through this a bit slower. So when it says cos equals, well, what do you know about cos? Cos theta equals, in a right angle triangle, car. So you've got saw, car, toa. So cos theta equals adjacent over hypotenuse. So because it's saying cos theta here, what that equals, my adjacent, we've got to first identify this is theta, not this is alpha. If it said cos alpha, then we would do it from this angle, okay? But we're referencing from this angle. So cos theta is adjacent. This is my adjacent. This is my opposite. This is my hypotenuse. Is going to be 7 over 25. And that's what I'll be putting in for my answer here. Pull up the fraction button here. 7 over 25. If things aren't going right, I would just like clear the whole answer, and like what I did before on that terrible, I've done some really good mistakes. Now, if it was cos theta, just imagine if it said, you know, this was find the angle of that, and down here it also said alpha. What I need to do, yeah, anyway, you get the idea. What I'd need to do there is, this is my reference angle. Oops, I want to change colors. This is now my reference angle. Okay, so we're talking about this one. That is now going to be, that's my opposite and that's my adjacent. So that is going to be adjacent over hypotenuse, which is 24 over 25. So just be wary of reading these questions and take note when you get two angles, you're using the correct one. Yeah, some people might have actually tried to solve for the angle, but it says cos theta. It's not just saying angle. If it did say that, then it would say find the angle. Therefore, then you'd need to do the inverse of cos 7 on 25, and that is different again. So you do true cos 7 on 25, and then you've got an angle of 73 point whatever. So that is a bit different. So just take note of those. Okay. I'm cracking my little boy there. Fun at home. Love my wife. She always takes care of me. To be 1.5, not even 1.5. All right, let's look at this one. The dimensions of the trapezoid prism are given, not drawn to scale. Find the surface area of the trapezoid prism. So we're trying to find the surface area, not the volume. So I've got 2 of these slanting edges, so I know that's 5 centimeters. So I'm going to calculate 2 of those. So I've got 2 lots of 5 by 10. Okay, I try and work systematically, 2 of those. I've got the top. I'm going to do the easy ones, which is 11 by 10, because that's the length of it. And I've only got 1 of those because the size underneath, now I'm going to go side underneath. So I kind of go side to sides. Some people like to go around, which is fine. But I sort of go, I like to match up my pairs. This plus, then I've got 19 by 10, which is underneath. Plus, I now have these 2 faces, the front and the back. So to find the area of these, it is the average of 19 and 11, the average of that and that, by 3. Okay, so you always take, this is where people stuff up, but if you've got this trapezoid, it's that plus that, and you halve them, take the average of those, and you multiply it by that. I can show you root proofs why, but I'm not going to. And that would be what it equals. So I'm going to now get out my calculator and go on my calculator. Where is my activity? Hello, I've lost you. There it is. Okay. I'm going to go with 2 by 5 by 10 plus 11 by 10. And what I'm doing here is actually at the same time, I'm looking at my input and I'm looking at this. So I'm looking at like 2 by 5 by 10 plus 11 by 10. So I'm kind of like correlating and I'm looking at the screen. 2 by 5 by 10 plus 11 by 10 by 10, because this is quite a long one, plus 19 by 10. So I've just checked that that is correct, and I've checked up here. Plus, so this is another way you could do it. I'm going to go with 0.5 times, open my bracket, 19 plus 11. Now, it's really important I use brackets here. If I don't, it's just going to do it as half of 19, half times 19 plus 11 times 3. So that does it a bit different rather than half of 19 plus 11. And then I'm going to hit execute to that. Now, I've double checked that. Now, because it's such a long calculation, it's really tricky, I find, to correlate that this is correct. So I find it sort of jumps over the place when I touch on it. So that's why when I get such a long calculation, I really slow down when I'm inputting it and trust that I've checked it correctly. So I'll just hit execute on that straight away and hope I got it. 445, does that sound realistic? It does. Centimeters. Oh, and they're all in centimeters. Yes, they are. So 445 is what I'm hoping. Now, it doesn't say to any decimal places, so I'm kind of happy with that, because if I had a decimal and didn't say to so many decimal places, I would redo it. So I'm kind of reading into the question. They haven't told me, so I'm kind of thinking, yeah, I reckon I've got that. Oh, and I didn't. Oh, there we go. After I talked about all that, surface area of the total prism. Okay, so I'll stuff that up. After I just talked myself up, that's rather funny. I should have gone back and checked it. 2 by 5 by 10 plus 11 by 10 plus 19 by 10 plus 0.5 by 19 plus 11 by 3. Oh, that was my fault. There's 2 of these. There's 2 of these, the front and the back. So going back, that was my error, not calculation error. There's 2 of those. I forgot to do 2 at the start. I said there was 2 and I didn't do 2. So as soon as I said there's 2 and I doubled it, I should have actually done the 2. Notice I did the 2 at the start here. I always like to do my doubles first, and I didn't do it there. And learn from your mistakes, where you go wrong, and that's why I stuffed that up. So I need to put the 2 in here. So I'm going to go back. So how I'm doing that is I click up in here, and just say if I miss it, I can just press across to get in. And then I'm just going to go plus 2 lots of do a bracket there, go all the way to the end, close my bracket there. 490. I lost half a mark. No. All right, there we go. Got it. Okay, but I'm not going to enter in the same number again. Damn it. All right, but learning from your mistakes is always good. The Bermuda Triangle is an area in the Atlantic Ocean where many planes and ships have mysteriously disappeared. I think Mr. Beast did an episode out there. It was rather funny. Its vertices, I don't know why I thought that. Bermuda, Miami, and Puerto Rico. So we've got all these ones here. Miami, Bermuda, and Puerto Rico. Don't go traveling out in there. It's just probably lots of rock seas and coral reefs. If the size of BMP, so we go BMP, so we're talking about the angle, because that is an angle, because it's not less than or equal to, because it's got a flat line underneath, is M, find the value of M rounded to the nearest minute. Okay, so, yep, it doesn't give me any information up here, right? But it's hidden in here. Oh, look, it's got kilometers in there and there. So I'm like, didn't give me any measurements. So we got everything. So I would probably, you'd have to use a cosine rule for this if you want to find an angle because you've got the 3 lengths. But we have this other thing. We have geometry, which is just great having one of these beautiful calculators. So I'm just going to start whacking in my information. 1770, lock it in 80. Why wouldn't I use this? 1609. 1529. Just going to double check I got everything correct because I haven't been on my game today. 170, yep. 9, yep. And 15, yep. So I want to know this angle in between 159 and 170. Rounded to the nearest minute. Oh, can you do this? Can we? Can we do this? Does it? No, it doesn't. Okay, damn. All right, we'll just go edit. We'll go copy. We'll quickly go back to main and we'll go edit. No, we won't. We'll bring up keyboard first and we'll do 2 decimal minutes and then we'll go edit and then we'll go paste. Okay, to the nearest minute, 48 seconds is going to round that up to, that's higher to 50 minutes than it is to 49 minutes. So 57, 50. So we're going to go in here, 57, bring up my angles, minutes. I think it was degrees, 50 minutes, I should say. 57 degrees and 50 minutes. Looks good to me. Input error. M equals, and it needs to be capital M. Not letting me do capital M. There, yes it is. Capital M. A, hence or otherwise, find the area taken up. Oh, well, this is where you would have to do Heron rule if you didn't have this type of lovely calculator. It'd be just so annoying with the sine rule, but you know what makes life so easy? Just click on the next one. Oh, there's my area. Oh, it's beautiful. Now it does say rounded to 2 decimal places, so we can't actually use that one. Bugger. What we can, there is a hack around this, which I don't really want to get into. So if you put that in, you'll find you probably won't get it because you've got to get the correct 2 decimal places. So we actually do need to go back and use the formula. We could scale it down because we do know that. So what I mean by that is you could kind of change this to like 1 point. So if I go edit, clear all, let's see if this works. I don't think it will, but let me just make this instead. It may not. 0.70. I'm just going to scale it down a bit. Keep it as a similar triangle. Line might be limited. 15.29. Okay, we've locked that in. Now we want to find the area. Sometimes this works. 155,419. That doesn't. Okay. So because they've done this with Mathspace rounded to the nearest minute, I would use that as your answer. I wouldn't use it as a decimal place. I'm going with that. And then we've got to use the rule for this too, which I'm just looking up because I always forget this one. Areas of triangles. It's a sine one. Where are we? So we want. What do we got? We're going to use the rule. Let's take a snippet of this. So I'm going to use the rule with, where's my pen? Oh, there it is. Okay. I'm going to use the rule of area equals half BC sine A. Okay. Which is basically, because we're given this angle in here, right? That's going to be, that's angle A, that's length A, that's B and C. So you just use the two adjacent angles, lengths. So the area will equal half of 1770 times, I'm going to round a room, so I'm going to do it down here. Sorry, 1529 times sine, and I'm going to do 57 degrees and 50 minutes is what I'm thinking. So I do believe that's how they want your answer. We'll see how that goes. So in my calculator, I am going to go with 0.5 times by 1770 times by 1529. And that's a problem. That's what they tend to do now sometimes in the exams. They give you these large numbers, so you can't use the number function, and you still need to use, they've kind of clued onto it, the examiners at times. Times sine 57 degrees, and I think I'm going to go 50 minutes by memory, but where's my minutes symbol? Maths 1. What is on the trig? There it is, Maths 3. Minutes. Okay, and hit close to that. Let's see how we go. No, invalid syntax. I knew we can do that. You've got the syntax there. It's the same one. There you go. Don't need it, maybe. No, that's not right. There is my minute symbol. I don't want to turn it into a decimal. I swear there's a minute symbol. I'll just hit the same one again. Let's have a look. That would make sense, but no, it doesn't. Oh, I just don't know where this was. I swear that's what it was there. So that should be minutes, and that should be degrees. Real deg, I am in degrees. Okay, I'm just going to check something. So I'm going to take the 50 minutes and divide that by 60, and that's what it is as a decimal. So then I'm just using my rounded answer. I'm just going to see if this works. Just bear with me, guys. So let's actually just use this as a whole number. Get rid of that O. That looks better. 141, 11454. Okay, so obviously they haven't used. Maybe I should use the original number. Let's see. Let's see how this works. I'm going to put that one in. I'm going to put in that answer because I know Mathspace, once you've used that, and they would normally say using your answer from part A in the exam. If they didn't, then you could accept 2 answers. But with Mathspace, I'm going to go with that, and we're going to put that answer in. 1415. Yep, so I've got to change the last one. So 458. Let's see that. 458.23. No, got it wrong. 458.28. Okay, there we go. So I got it right. So what you got to do with Mathspace is if I've found out my answer before, you have to use that to help you solve the next one. So to convert from minutes, you need to divide by 60 to a decimal and then put that in there. Unless someone else knows a way of how to put in that, which I thought that would work, but obviously it doesn't. That's kind of disappointing. Syntax. Maybe, do I need to put a 0 after it? I really thought that was minutes. I'll have to do some research on that one, let you guys know. Unless it's treating it as a symbol rather than a. This is math. No. This is bothering me, if you can't tell. Probably bothered you guys too. Yes, here, this one. Bet you it's that one. Really? I thought I was onto it. Oh, let's move on. I will try and find it for you guys a little bit later on. This is a symbol, so I don't think this will work. I'll be very surprised. No. One doesn't work. And this is a symbol, so I don't see how that's going to work. No, look at that, you got a club and everything. All right, let's move on. Anyway, I can do it. Just convert it back into a decimal and do it that way. So divide by 60. All right, I can see why you guys struggle with that one.
I'm
yes?
pretty sure next to DMS, you see the 3 boxes.
Where were you on this before, Tyler? This one. This one.
No, 3 boxes. Yeah, if you click that, it comes with like the 3 symbols.
Are you trying to do this?
Click the button next to.
Yeah,
DMS.
hang on. I'm just going to copy this down. I see what you're saying. Thanks. Because we don't normally deal with minutes and things like that in here.
Is it going to be on our
It could be on your. It could be because they generate different numbers. That's why. Thank you. And that would be 0, right?
Yeah.
It was so obvious. It was right next to. There's my degrees, minutes, and seconds, and there's 2 degrees, minutes, and seconds. Wow. Awesome. Love it. Thank you very much. So this symbol here. Did you already know about that?
I just looked at the calculator and I pressed all the buttons.
Press them all. It kind of makes sense. It's right next to it now. Now it's so obvious, isn't it? It's like, oh, it's right there. So yeah, perfect. So we can do that, and then we can do 57, and then we can do 50 because that was our previous answer, and we're gonna have to put in 0 there, and then that was the answer we're looking for, right? That was it, wasn't it? I think it was. I've missed it. It seems right. It should be the same as that one. Spot on. Yay! Big round of applause. Saved us twice on that one. Good job. There we go. That's even easier. Saves us a step. I'm always up for saving a step. Well done. Thank you, Tyler. There you go. Much easier. All right. That makes my life so much easier. Moving on. I feel like we did this one. We did do that one. Okay. During football training, the coach marks out the perimeter of a triangular course that players need to run. The diagram shows measurements of the course where the side length of A is 14. Okay. Find the interior angle of A. So it's going to be 180 minus 81 minus 75. 24, that sounds right, you know, ish, that's what I expect. So that's just in degrees. 24, it says degrees there. Find the length of C, round your answer to 2 decimal places. So the length of C, we could use the sine rule if you wanted to. That's what it's trying to do. Again, you can use the sine rule. I'll probably use the geometry function, but let's use the sine rule anyway, because I haven't used that one in a while. So the easiest way to do the sine rule is literally in here, bring up trig. We want to do the sine of, we want to find the length of B, was it? C. Okay, so we want to do the sine of 81 on X, which is what we want to find. And then hit out, and then do is equal to, and this should work, I believe, equals the sine of what we just found out, because you've got a pair of 24, close my bracket, and 14. And then I can solve that. Now make sure we're in real deg. You always want to make sure you're in degrees. Calculate, solve, calculation. Actions. Advanced, solve. That's where I want to go. Oh, I just got rid of it. I wanted to do interactions, not actions. That's what I did wrong. Interactivity, advanced, solve. Because interactivity means what you've already got highlighted. Where, why does it say no real calc? Oops, because I've used the wrong sign there. It should be sine, the normal sign, not sine to the power of 1. And then you've got 33.999. So to 2 decimal places, 996. So that's actually going to be 34. So this would be 34.00. Now I'm just going to put in 34 and see what, hopefully it gives me a mistake. I'm interested. And I need to do C equals because it doesn't have C at the start. So I get an error. Oh, I've crashed Mathspace. Oh, it accepted it. Okay, which is technically, I suppose, correct because it's 0.00, but I wouldn't accept it. I would possibly tell you guys it did say 2 decimal places, so you should actually do 0.00. For my numbers, that's just how it seemed to work. So still putting in decimal places. Find the side length of B, round your decimal place to 2 decimal places. So now I've already got one pair. I've already got this pair. So to find B, I'm just going to click back up here and change this to 75. And that's the beauty of already having it going. 33.25. So here I definitely need to do 33.25. I should just double check. Yep. Oh, I haven't written B equals. B equals. Each player is to sprint 1 lap and then jog 1 lap, alternatively doing each 3 times. If Lisa can run 200 meters a minute and jog at half the speed she runs, how long will this exercise take her? So she does, how long's a lap first? So a lap is going to be, let's use the rounded answers, okay? So we've got 14 plus 34 plus 33.25, use your rounded answers. 14 plus 34 plus, yep, okay, so that's how far a lap is. And she can run 200 meters, so she does 3 of those. So let's just do both of these separately. So if she can run that at per minute, I'm going to divide that by 200. So it takes her to run 3 laps, 1.21 minutes. I'm going to leave that as a decimal. And then don't forget, I already know how far it is here. So this is the total distance to do 3 laps. How long does it take her to jog that? She jogs at half the speed. So half the speed would be at 100. That's how long it takes her to jog that. Now I can add these 2 together. So plus and highlight that one and bring that down. So that's the time it takes to run 3 laps and the time it takes to jog. Add that together. That is in minutes, okay? So round your answer to 1 decimal place, it does 1 seconds, so it's going to be 3.7. Any questions, please let me know. Consider point A. Find 3-figure point bearing of point A from O. So from O, 3 point, that would be 360 minus 30, 330. Do I need to put bearings in there? Doesn't come up with it. The degree symbol's out here. Good. I was getting a bit worried. What is the compass bearing of, hey, look, it's got those three things, of A from O? Of A, okay, of A from O. So A is north, 30 degrees to the west. So we always measure those from north and from south. And is that it? No, one more. Then we're done. Oh, this is pretty much similar. If I want to build a fence around the entire perimeter of his land as shown in the diagram, fencing is $26 per meter. What is the value of X? So to find out, X is here. You can see that that's going to be 2, and that's going to be 4. So 2 squared plus 4 squared is going to be 4 and 16. That's going to be 20, the square root of 20, around your answer. 4.47, which makes sense. Oops, X equals. What is the value of Y? Y is here, so we have 2 plus 3 is 5, and this is going to be 2. So it's going to be 5 squared, which is 25. 2 squared is 4, it's the square root of 29. Pythagoras, 5.39. That makes sense, because if it's fencing, you do it to the nearest centimetre. How many meters of fencing does a farmer need if fencing is sold by the metre? Okay, let's add that up. So I'm going to go with 1 plus 6. So I'm kind of starting here. I'm going to go around. Plus Y. What was Y that we said? Plus 5.39 plus 2 plus X. And that takes me right back to the start. 4.47. 18.86. Oh, it's sold by the meter. Oh, that was lucky. It gave me a tick as well. You would have lost a mark there for sure, because it's to the nearest meter. At $26 per meter fencing, how much will it cost him to build a fence along the time perimeter? So it's going to be, because it's sold per the meter, that means I've got to do 19 by 26. Of course, it's done by the meter. 494. And we're done. And that is it. Hopefully, it kind of helped